All right, guys, we are on Unit 5, Day 1, and this unit is called Exponential Functions. And so we're going to talk about lots and lots of exponents on these first couple days and their properties. We'll talk about exponential growth and decay and all that fun stuff in this unit. So first off, we got to know our basics, and that is our exponent properties. Some of these you should already know, like the first two, and then we're really going to have to work on the third one, and the last one is very easy. All right, so multiplication law. If you have the same base, for instance, these two right here have a base of x, then there is something you can do with their exponents. When your operation is multiplication, your exponents actually get added. All right, so x to the 5th times x to the 7th is x to the 12th. Okay. And if you do forget the properties, you can always go ahead and write them out long way too. For instance, x to the 5th really means x times x times x times x times x times x to the 7th, which is 7 more of these. And so if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can see where the property comes from, where the little shortcut comes from. All right. All right. So then the next question over here is a little bit longer. You have a monomial times a monomial. All right. What you do with those is you take the coefficients and you multiply those like normal. Okay. You don't add those because they're coefficients. So 2 times -5 is -10. But then you have x squared times x. And so you add the exponents there and you get x to the 3rd. Because technically there's a little 1 here. All right. And then y times y to the 5th, add the exponents and you get y to the 6th. Okay. All right. So next rule. They're talking about division, which is the opposite of multiplication. So you do the opposite for the exponents. Instead of adding them, this time you're going to subtract them. Okay. Sometimes I don't subtract. Sometimes I'll just think, well, it is still subtraction, but where are there more A's left? So you can figure out would it be on the top or on the bottom. So for instance, on this one, you have the same base of A. And so we're dividing. And so you could see the exponents and you would go ahead and take the top one and subtract the bottom one. And so we would get A to the 3rd. Okay. In the next one here, a little bit more complicated because you have expressions, but you do see the same base of g, and so you would take that top exponent, which is x plus 3, and you would subtract the bottom one, which is x, and what's going to happen is that this x and that minus x will actually cancel each other out, and you just left with g to the 3rd. Okay. Next rule is a little bit tricky for a lot of people, and it's called an exponent raised to an exponent, or the power law. Okay, I'm going to scroll up a little bit. And here you're going to go ahead and see what happens, but you actually multiply the exponents. Okay, so for instance, x to the 3rd to the 4th is actually x to the 12th. And here's why. X to the 3rd, basically this means x to the 3rd being multiplied by x to the 3rd 4 times. So x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. And when you turn it into multiplication like that, then it becomes you add the exponents. And so you can see 3 plus 3 plus 3 plus 3 would be x to the 12th. Or you could write it out like we did on the top one. All right, but that's where that rule comes from. Okay. In the next one here, what a lot of people will miss is that that little 3 on the outside here, how many times you have to use it. A lot of people only think twice. However, the 5 is in the parentheses raised to the 3rd power 2. And so you have to raise the 5 to the 3rd. You have to raise x to the 6th to the 3rd. And you have to raise y squared to the 3rd. So it becomes 5 to the 3rd, x to the 6th to the 3rd, and y squared to the 3rd. All right, 5 to the 3rd in your calculator is 125. And then here you have an exponent raised to an exponent, so you multiply them, and you get x to the 18th. And you got another exponent raised to an exponent, and so that would be y to the 6th. Okay. In the next one, when you have a fraction, you have to raise everything in that set of parentheses. That's a base, okay? All numerical bases and all variable bases raised to that 4th power. All right, and so here's what the top is going to turn into. It's going to turn into 3 to the 4th, and then y squared to the fourth. Okay. On the bottom, that becomes 5 to the fourth, and then x cubed to the fourth. Okay, so basically that exponent is getting distributed, and you can do that over multiplication and division. Okay. All right. So take your calculator, type in 3 to the fourth, and you're going to end up with 81. Here, that's y squared to the fourth, an exponent raised to an exponent. You multiply them, you get y to the eighth. And on the bottom, type in your calculator, 5 to the fourth is 625. Okay. And then you have x cubed raised to the fourth. Okay, so an exponent raised to an exponent, you multiply them, and you get x to the 12th. Okay. The only thing you're going to double check to see if your coefficients out in front, your 81 over 625, if that can be reduced. And all you have to do to check that is type it in your calculator. Do 81 divided by 625, okay, hit enter. Math bracket, hit enter. If it doesn't change, then it can't be reduced. And 81 over 625, there are no numbers other than 1 that go into both those numbers, so it can't be reduced. Okay, and you'll see y on top as your base and x on the bottom as your base, so you can't do anything with those exponents either because they have different bases. So that's finished. Okay, on to the next one, 0 exponents. Anything to the 0 exponent, it actually equals 1. And you could test it in your calculator. You could take any number that you want. Like, for instance, 13 is my favorite number. If I raise it to the raise it to the 0 power, 13 raised to the 0 power is 1. Okay, so x raised to the 0 power is 1. Okay, anything raised to the 0 power is 1. You just have to be careful that you have everything grouped raised to the 0 power. So for instance, here's our 0 power. Okay? Notice that it is raising everything because of the parentheses around it. And so your answer will be 1. Okay. Again, here's your 0 power, and there's your parentheses raising everything to the 0 power. And so that will be 1. Okay. However, in here, in this last example, there's no parentheses. If there were, then I would say the answer is 1. But we're going to have to say and be very picky, and this is going to happen throughout the unit, okay, that only b is being raised to the 0 power. So only b raised to the 0 power is going to give you a 1. The negative 5 is still going to be there times that 1, and your answer is actually negative 5. Okay, so it gets a little bit tricky. In the last one there, negative exponents. Okay, also something that a lot of people struggle with. What happens with a negative exponent is that the negative exponent actually forces this to go into the denominator. Okay, and in order for that to go in the denominator, and there's nothing in the numerator, there has to be something in there in order to hold what's in the denominator down. So it's 1 over x to the n. Okay. All right, so in this example here, notice that there's no parentheses around the 7y. So the only thing that's being raised to the negative exponent is the y. So the 7 can go ahead and stay upstairs, okay, or in the numerator. And y squared will go in the denominator, but when it goes in the denominator, the exponent becomes positive. Okay. You'll often be asked to rewrite negative exponents as positive ones. Okay, so in this next example, notice everything's being raised to the negative second power. So everything is going to go downstairs. All right. And so you're going to end up with 7y, make sure you use parentheses, raised to the positive 2. But notice that there's nothing in the numerator left, and so we will have to put a 1 up there. Okay. We can go one more step based on what we just talked about in the last rule. But 7 is going to be raised to the second power, and y is going to be raised to the second power. And so to simplify our answer a little bit more, we can say that answer is equivalent to 1 over 7 raised to the second power is 49. Y raised to the second power will be y squared. And there's our final answer. Okay. All right, last one. What happens if you're a negative exponent and you're already downstairs? Well, then you're going to come upstairs, okay, into the numerator. And so on the top, there are no negative exponents, and so that's going to stay negative 5y. Okay? But this is going to come upstairs and become a positive exponent, so x cubed. Okay? The only thing I don't like about that is that the y is first and the x is second. Alphabetical order, you would more so see that written as negative 5x cubed y. Okay, just a little reordering, which you can do, okay, because multiplication is commutative. All right, let's practice a bunch of examples and see what we learn. Okay, so in number 1, it says simplify each of the following with positive exponents only. So there's our rules. Okay, in the very first one, we see a 4 on the outside, and we see a numerical base on the inside and a variable base. So this would be the same thing as 3 raised to the fourth, and then d cubed raised to the fourth. Okay? In your calculator, 3 to the fourth is 81. And our rule here is that you multiply them. So 3 times 4 would be d to the 12th. Okay. In the next one, there's no exponents outside the parentheses, and so this is just a monomial times a monomial, and we're going to go ahead and multiply our coefficients. So 4 times 3 is 12. Okay. We have an x here times an x to the 6, which we're going to add our exponents because our operation is multiplication. We add our exponents, so x to the 7th. Okay. Y to the 4th and y to the 9th, add your exponents. You get y to the 13th. And z squared and z squared, when they're multiplied, you add their exponents, you get z to the 4th. Okay. All right, last one on this page. On the top, there's parentheses with the 4 on the outside, and so the top is going to be rewritten as x to the 4th, y to the 4th. Okay. On the bottom, there's no parentheses. There's actually nothing to do, and so we're just going to keep it. Okay. However, now we got to go ahead and look at these. X to the 4th divided by x. Okay. When you're dividing, you're going to subtract your exponents. Okay. And so you're going to get x cubed on top. Okay. With the y's, y to the 4th divided by y cubed, go ahead and subtract, and you end up with y. Okay. And both, there's more x's on top. That's why my x's here are left on top, nobody on the bottom. Okay. And here, there's more y's, and so that's why my y is also left on top, next to the x cubed. Okay, there is no denominator unless you want to put it over 1, but you don't have to. Okay, all right. Hopefully that helps, and I'll see you guys on the back side of notes.